Dan, what sort of problems are you solving for your customers with the RF power tool system?
Great question, Megan. The biggest problem our customers face is complexity. Complexity at two different levels. Complexity in trying to determine which of the RF power components work best for them in their application, and complexity once they make that decision in developing their application. Product development application environment is complex for a number of different reasons. One is the number of tools that a customer has to use, the overall size of those tools. A large bench can encompass 8 feet in space. Lab space is always at a premium in any product company. And then lastly is the complexity of interfacing with all those tools and the cost of those tools, which can run in excess of $100,000. The RF power tool, which comes only from Freescale, is intended to solve those problems clearly in a very compact, integrated form factor, but which encompasses all of the functional attributes of a RF bench in a box.
Okay.
So we've got power metering, signal generating capabilities, voltmeters, ammeters, bias control for the RF power stages, as well as a very simple and intuitive graphical user interface built on LabVIEW, and seamless interface in working with Freescale evaluation boards for both their component evaluation as well as application development. So the benefits that the customers get out of this solution is clearly size and space. So it's a very small, compact solution for all of their application evaluation and development needs. Very low cost, so as opposed to hundreds of thousands of dollars for a fully instrumented RF bench, it's $5,000 for the power tool system and then separate charge for the evaluation board. It's a fully integrated and seamless interface to work with the evaluation boards from our industrial portfolio. It also incorporates all of the interfaces for all of the RF functionality that I described before, in terms of being able to make all of your RF settings, as well as to be able to read in real time the results of those attributes, as well as the performance attributes of the evaluation board as it's actually operating. And then to be able to collect all that information, that data, and to do data logging so that they can evaluate the real-time performance of the device under varying conditions and fold that into their application development.
This GUI here will be supplied with the RF power tool, and you can actually do all the work just from the power tool, but this will make it easier for the engineer to evaluate it. As you can see here on the monitor, inside of this evaluation board there's 3 stages. Our MHT1003 and our MHT2000 two-stage driver is inside of this. Here we're monitoring the finals voltage, the driver, and then here we can set the biases on the PA, and as we turn that on, the light is green, it'll bias the part up. Then as we also go and bias the additional drivers, turn this on, monitoring here, you can see that the final is drawing 100 milliamps. That's where we bias it, and we turn on the drivers. And now the driver is also biased up. We're monitoring the temperature of the final and the drivers. We then have a SIGGEN built in this box.
Okay.
So this box here is the SIGGEN. It also has all the meters in it for power, reflected power, power of the drivers. It also monitors the currents, the voltages, and the temperatures. It's also capable of doing CW and pulse. It works from 10 megahertz all the way to 3 gigahertz. So in this demo here, I'm going to show you that this is our 2.45 gigahertz parts for microwave heating. And as I turn on the RF power here, and I turn up the power, you can see here on the GUI that we're delivering roughly for this demo 115 watts. This is measuring reflected power, so then you know what the VSWR is, which is very important to our customers. Also, it shows your drive power and your power out of your driver.
Okay.
So our customers will be able to take these two, power tool and the evaluation circuit, and completely do a evaluation of our power transistors for their applications without needing this very complex bench with just these two components.
When you were designing this particular system, what were some of the challenges that you encountered?
Well, certainly space, because we're trying to take a number of different functions that clearly come in a variety of different discrete RF bench type tools and compress them physically into a small size. And what we did to enable that was really to focus on the range of functions and performance attributes that our customers need for the types of applications they're developing with the components that Freescale has available. So we range from a low of a few megahertz in terms of frequency generation all the way up to 3 gigahertz, and that encompasses our entire portfolio. We also range from just a couple of watts of output power to well over a kilowatt of output power. Again, that encompasses the portfolio range that Freescale offers to our customers. So rather than give them functionality or attributes in an instrument that they don't need for the types of components that they're designing with, we really selected the range that they can make most effective use.
And in your opinion, what is the one feature from this system that sets you apart from the rest of the competitors out there in the market?
Ease of use. Ease of use is really the focal point. So literally you can receive a unit from Freescale, take it out of its box, in a very simple setup, in less than 5 minutes be operating the device that you want to be working with.
Great, well thanks Dan for your time, we appreciate it.
Thanks for coming by.
I'm Megan Zimba from Wireless Design and Development. Thanks for joining us. See you next time.